Okay, I'm going to make a video here for the introduction to our next unit, Unit 3, Organic Chemistry. And that's because the video I have online, the second half of the video you can't hear very well, so I figured I would just make a new video. All right, so this unit is on something called organic chemistry. So let's talk about what organic chemistry is. All right, so organic chemistry, and I might go quickly through this, so you may have to pause in order to write the slide, or you can go to the PowerPoint. So organic chemistry is really the chemistry of carbon. All right, so carbon compounds. Carbon is the principal element. All right, now carbon can be bonded to other elements such as hydrogen, oxygen, nitrogen, but carbon is the main element. Let me give you an example of what that might look like. So what a chemical might look like that's made up of primarily carbon. So if I had maybe a chain, maybe of 4 carbons, I could then put hydrogens on this one, and there could maybe be an oxygen here, or there could be maybe a nitrogen that has its 2 hydrogens, and then maybe some more hydrogens. All right, so you can see there we've got an interesting chemical that contains all kinds of things like carbon, hydrogen, and nitrogen, but the main thing is that carbon is the main guy. And the other thing that you can notice is that the carbon here is bonded always with 4 bonds. All right, 1, 2, 3, 4. All right, this guy here, 1, 2, and then 3, 4 with the oxygen. This guy here, 1, 2. Oops, I'm missing one on this one. This is a mistake. 1, 2. I would need a double bond somewhere now, so I've got a mistake somewhere. This guy actually should also have another hydrogen down here. All right, so I caught my own mistake there. 1, 2, 3, 4, and again 1, 2, 3, 4. All right. So carbon is a very versatile element because it can bond with 4 bonds with many other elements. And the reason it can do that, all right, if we take a look at our periodic table, the reason we can do that is the fact that carbon is in group 14, right? So if we zoom in over here to carbon, right, carbon is in group 14, which means that we can bond with 4 different things. All right, so it has 4 lone electrons. All right, so that's what makes carbon so useful and so versatile, is that it looks like this. This is Lewis diagram, and it can bond with 4 things. All right, okay. So some other important information is that there are some carbon compounds that aren't organic. Carbon monoxide, carbon dioxide, all right, that's a carbonate ion, that's a bicarbonate ion, and that's a cyanide ion, and you can see that they're not organic compounds because in these molecules the carbon is not bonded to other carbons. All right, so we need the carbon bonded to other carbons. Okay. There are millions and millions of ways in which you can combine carbon together to make these compounds, so there are all kinds of different organic compounds. But we see them in everyday life all the time. All right, there are many naturally occurring compounds. Glucose is a type of sugar that's used by our cells, right, that keeps us alive. Sucrose, that's the sugar you put in your coffee, all right, so that's a very important food, all right. DNA, that's the part of our cells that give the instructions to the cells on what to do and how to behave. And then there's all kinds of interesting things. Oils, natural oils like olive oil, etc., fats. Cellulose is found in trees, right? That's like tree fibers. Starch, that's found in corn and things like that. All right. There are many man-made ones, plastics, all kinds of plastics that you encounter in your daily life. Many medicines are synthetically made. All right. Now gasoline does come out of the ground. It comes from fossil fuels. So you might argue that it might be naturally occurring. Yeah, that wouldn't be a bad argument. Same with some alcohols. Some alcohols are created by fermentation by various types of yeast, and therefore you could argue that that is also naturally occurring. But I'm not going to be asking you to state one versus the other. Plastics are obvious, right? Medicines, there could be some naturally occurring medicines, but don't worry about that type of information. Okay, so let's move on and talk why carbon is important. Again, I'm going fairly quickly, so if you have to pause the video in order to write everything down, by all means do that. So carbon has 4 unpaired valence electrons. I drew that a moment ago. Looks like that. My dots are tiny, but they're there. And that's what allows them to bond in all kinds of different ways. Right here, you can see here we've got that particular chain of carbon. Here we've got a ring of carbon. All right. So there are many ways in which carbon can bond. As it says in part 2, it can form chains and rings and spheres and sheets and tubes. And here we've got a picture of some of those different things down here, right? This is diamond, all right? This is sheets of graphite. These are spheres and tubes, all kinds of different ways in which carbon can form bonds, all right? Again, one of the reasons carbon is so versatile is not only can it form single bonds, but it can form double bonds and triple bonds and all kinds of different ways in which carbon can bond. All right, and that's what organic chemistry is about. It's all the different ways in which carbon can form bonds. All right? Okay. So the first part of the unit, we're going to talk just about something called hydrocarbons. And that's easy. It means they contain only carbon and hydrogen. None of the other elements that were mentioned above, like the nitrogen and the oxygen. Okay? Today, you're going to learn more about what are called alkanes. All right? And alkanes contain all single bonds. All right? So that's how you identify an alkane. It has all single bonds. And that's what we're going to talk about today, how to draw and name some alkanes. Alkenes contain at least one double bond. All right? At least one double bond. So if there's one double bond in there, we call it an alkene. So the E tells you double bond. The ane tells you single bonds. Alkynes, the Y tells you that there is at least one triple bond. All right? At least one triple bond. So the Y tells you that there is at least one triple bond. All right? Okay? So today we're going to look at alkanes. In the next videos, you'll look at alkenes and alkynes, and we will learn about the different reactions. Today we're going to learn how to name the alkanes and how to draw them. Okay? Now at this point, if I was in the classroom, I would watch a video. This video is on Google Classroom, and it goes over sources, all right, sources of hydrocarbon. That's horrendous spelling, but sources of hydrocarbons. And most hydrocarbons come from crude oil. All right, whoops, crude oil. All right, and that's what that video talks about. It's a good little video. You only need to watch about the first 10 minutes. All right, and you'll know when it gets into the naming part, you can stop if you want to watch it. It's got some good information. It talks about the different types of fuel that can come from crude oil. All right, so it's got some good information in there. I'm going to continue at this point, though, because you can always go and look at that video. All right. One last little thing. Alkanes, as we stated, they contain only single bonds. We've already got that information. And we also say that they are saturated. All right. Now, what does saturated mean? Saturated means they contain the maximum number of hydrogen atoms bonded to each carbon. Let me draw a picture to represent that. Let's say I had a chain of carbons that had 3 carbons. And because each carbon gets 4 bonds, I can put lines like that to make sure that there are 4 lines coming from each carbon. And I'm going to put a hydrogen at the end. Remember, hydrogen only needs 1 bond, and that's because it only needs 2 electrons in its outer shell. Now, this particular hydrocarbon contains 1, 2, 3, 4, 5, 6, 7. It contains 8 H's. Okay? Now, I could draw another version of a hydrocarbon that has 3 carbons, and I'm going to put a double bond between the first and the second carbon here. Now that means I only need 2 more lines on this first carbon to get 4 lines. The second carbon has 3 lines, so I'll give it 1 line to give it 4 lines. And the third carbon needs again 3 lines. And again, if I put them as hydrogens, I now have all of the carbons with 4 lines. But this time, if I count the number of hydrogens, I only have 6 hydrogens. All right? And my last one had 8 hydrogens. Okay? You'll notice I can't put any more hydrogens on this guy. This guy is saturated with hydrogen. I couldn't put any more hydrogen on it. This guy right here, if I were to break the double bond right there, open that up, I could put 2 more hydrogens on there, which means it is, oops, not sun. Let me fix that. Click, click. It is unsaturated. So we say that that's unsaturated. So saturated means it can't have any more, and it has all single bonds. All right? You've probably heard of the term saturated in association with things like fats, saturated fats. They're typically not good for you. And you can see here, animal fats tend to be saturated. Things like butter, milk, bacon fat, etc., etc. And they tend to clog your arteries, so we want to limit the amount of bacon fat that we have. But it is delicious. Okay, now, the next part of this video is on name